expect it to be. So this was just a recall on this sort of thing. So the exponential functions, so when we think of a function, f is said to be exponential if it is of the form f of x equals to c times b raised to the x. And this is very important in financial applications. This is a model that one would use. So this represents a model for in financial applications. I'll name a few. Another one is spread of a virus. Does anyone know what, so spread of a virus, we don't have to look very far. We're in this pandemic business with the COVID-19. Does anyone know what carbon dating is? Anyone? Have you ever heard of that before?
I think I did it in chemistry, but I'm
good.
not sure if that's or the same thing.
This is air pollution?
No, so I think you're right in thinking of it as chemistry, as a chemistry example.
Because you could like see how old something is by just
that's what
carbon
it is.
dating it.
I mean, I hope you guys weren't thinking of dating as some other word. Sorry. I've gotten strange answers in the past from students, but if you haven't heard about it, you might want to take a stab, but it might not be the right thing. So you're absolutely correct. So I'm fairly certain most of you have like gone on a school trip where they'll take us to a museum or something. You might not remember much, or you might have watched a movie where, like they had these movies, like a whole bunch of, well, when I say a bunch of them, maybe parts 1, 2, and 3 or something with the mummy. You might have seen that. But the idea is, how do we know how old those things are? So there's a technique that's called carbon dating. And that is used to figure out how old these things are. So basically, this is very important, these exponential functions. And this model where you have f of x is some constant times b to the x, this is super important. So there are many, many applications of this. If you own a credit card and you shop with it, and many of my students do, many of us use credit cards. So ultimately, what would happen, there's interest that you have to pay. So that interest that you pay, I mean, it's calculated using an exponential model. So an exponential things grow quickly or they decay quickly. So it's a very important. So there's this thing called carbon dating, and then radiation decay. So radiation decay basically behaves like an exponential model of this form. So there are these options where you can, basically work on these things. And you're absolutely correct, Gustavo. Yes, there is half-life. So if you've seen this, and I'm not going to go into chemistry or anything, but we are going to talk about half-life. Now, I mentioned spread of a virus, but in general, it can be growth or decay. So for us in the United States, we're happy if this curve is decaying, because it means like there are less and less cases. Because the way the virus was growing is like an exponential curve initially. And right now, the numbers show that it's going down. So there is that business, and we're hopeful that that's the way it is. So there are all of these options, and this is very important as a topic. So it's not a random thing that's thrown in there, but it has very many applications. And for those of you who go on to do Calculus 1, you'll see this again, and in Calc 2 in particular, these exponential functions come up a lot. So there are a whole slew of examples where I can talk about this. So I'm not saying, you might be familiar with this, but one of the things that people do is test your breath to see if you have alcohol in your body. And so there's a breathalyzer test, and it works based on an exponential model also. So, the longer, so let's say someone consume alcohol, and the longer it takes, so let's say they consume a certain amount, and so let's say it happened at 10 o'clock this morning. At this point, because it decays exponentially in your body in some sense, it may not show up, and that's a good thing because you'll be considered sober, so to speak. And then there are numbers that people use in this context. So that's just about these functions. I haven't done anything with them, but I can assure you we will study applications which deals with growth and decay. And in particular, and I deliberately didn't write it out, but the one main example would be like spread of a virus. So the one I didn't write out is population growth in general, but that's part of the spread of the population of a virus. But to be more precise, our population grows exponentially. The human population, you can model it exponentially. It's not 100% accurate, but close enough. And people do that all the time. So one of the things you would want to do, and let's draw some graphs. So suppose I look at f of x, which is equal to 2 to the x. So in general, I gave you this model, which is c times b to the x. So in this problem, I'm letting c equals to 1 and b equals to 2. Now, if you draw a graph of this, 2 to the x, when x is 0, 2 to the 0 is 1, so this is equal to 1. And if you plot this with your calculator, this is what you'll get. And this is exponential growth. And I want to point out that in general, for f of x equals to c times b to the x, when b is greater than 1, we have exponential growth. Right? And you don't have to take my word for it. Like, suppose we do f of x equals 5 to the x. Well, if you do that, then, it grows like that. So this is 2 to the x. And we can draw a whole slew of these. And this one is 5 to the x, for example. So we can keep going on and on and on. So an important feature of exponential graphs are, number one, the domain is all reals. And I'll write it as minus infinity to infinity. Number two, so I have to be careful, but if I'm doing, and I'm talking about f of x equals c b to the x, the x-axis is a horizontal asymptote. So in other words, and I'll try to highlight this graph goes all the way, and this is the x-axis, but it never touches it, right? So those are important features. I just want to check through my list. Giovanna, are you here? I'm just looking through, but I don't see her. All right, just had a question. Now, when I did things that are greater than 1, right here, we get exponential growth. So when b is less than 1, what happens? And that's something we're interested in. May I go to the next page? Let me know if I need to come back. Sure. Yeah, I don't mind waiting at all. All right, guys, I think I'm allowed to go. We're good. Let me go to page 4. So we're still looking at f of x equals c times b to the x. So if b is less than 1, so I'm interested in positive values. So 0 less than b, which is less than 1. We will consider this to be a decay. So these are my options. Get an exponential decay. So now if we enter y1 equals to 2 to the x, pardon me, 1/2 to the x. So here c is equal to 1 and b is equal to 1/2, which is clearly less than 1. So I claim that I have exponential decay here. And you can enter this in your calculator, of course. Just to make sure we're on the same page, I would enter y1 and I would put 0.5 and then enter this symbol. And then I would just put x. So that's important. If you're using the calculator. Now, what is interesting is if you draw this at x equals to 0 again, y is 1, but now it's a decay, so it's dropping, so it goes like this. And here again, as before, I didn't specify whether it was growth or decay. But I just want to comment that whether it's a growth or a decay, once it's of this form, this line y equals to 0, or the x-axis, is a horizontal asymptote. So just to allude to an example I mentioned earlier, and some of you might have seen this obviously in chemistry. Let's say you start with 20 grams of plutonium, which is a radioactive substance. In a certain time, I'm going to call it T1, it goes down to 10 grams. And then in another time, and it turns out it's the same time, it goes down to half its amount, and it goes down like that, and it actually decays exponentially. Now, this is actually a bad thing. Why is it a bad thing? Well, for starters, when this radiation gets into your body, if it reaches a certain critical amount, you can get cancer. So it has been shown that, excessive radiation from these things can cause cancer. So one of the things, it's not practical for us to do this in real life, but if you don't want radiation to go into your body, you'll have to wear on these copper suits because copper, basically stops it. But the idea is when we take these substances to create these atomic bombs, for example, these nuclear bombs, as they call them, they have to use these radioactive substances. And once they start radiating material, it doesn't die away. We can't just dump it. It just keeps radiating until its half-life is done. And you might say, well, gee, if it goes down in that amount in half a day or something, that's fine. But these things can take like 2,300 years and so on, So once you start playing around with these things and they start radiating things, you have to put them in special cases. And, people have been known to dump these things in very unsafe ways. And so if you're living in a particular place where, an industrial dump was once at, where they had dumped these things, there's good chance that you can get really ill without knowing what's happening because it's invisible. It's not something that you see. So it's important to know about these things, and hopefully one of you or a group of you will come up with a way to nullify these things harmlessly, because they've tried, but they haven't gotten a particular way to basically nullify these radioactive substances. So there's uranium, which is very popular, and that's probably like about 2,300 years or somewhere. And there are other ones, like one of you mentioned, thorium, and so on. But the idea is, you have to be careful. Now, by the way, we get incidental radiation in our body all the time. That phone of ours that we're so happy with, well, it has a lithium cell in there, but they consider it background radiation. If you hop on a plane, as soon as it goes to the outer atmosphere, you get exposed to radiation. If you watch television, you get hit with radiation, but that's very minimal. It's not a large amount. You can live through your entire life, and you're usually okay with that. But if you're getting X-rays and all kinds of other rays, things can get really complicated. But anyways, so I wanted to motivate and indicate that this is a super important topic. And no, thankfully no. However, jokes aside, and I thought that was funny, if you go for certain treatment at the hospital, they do say that you shouldn't interact with little kids and things like that, because your body do radiate some of these things, the things that you input in there. But overall, I'm gonna hope that we don't radiate too much strange stuff. Right. All right. So so we have this idea of what an exponential function is, and this is nice. This is something interesting, and so we see what's happening with that. Now, we talked about inverse functions in this class. So the claim, if f of x is equal to e to the x, then f inverse of x is equal to log x. Proof. And so a few comments on the side, because I graded your exam. So some of you messed up in the piecewise function, so please go over that. I will, of course, put up the solutions if I didn't do so already, so you can access that. So kindly go over that. And with the inverse function that you guys did, you claimed that the domain was, I didn't ask for it, but you claimed that the domain was from minus infinity to infinity. You got to be careful, because if the denominator is 0 and the denominator can be 0 at some x value, you have to exclude that. So you can't just claim that's the whole thing. So I just wanted to, make sure that you're aware of that. Yeah, and just as an aside with the what Lily said, so if you work in those fields, you make some really, really serious money. So I usually look at the job outputs, and people sometimes make 250 grand a year in those fields, once they're willing to do it. So you can make some serious money in that field, but you have to wear, they call this thing a rate meter, because they have to make sure you don't have too much radiation in your body, where it meets, they'll tell you, well, you want to stay away from stuff.
Professor, what does it say next to the equal sign?
Let me highlight, because I'm not sure here.
To the right. E, is that E and X?
It's ln.
L and X. Okay.
All right, so my ln has this hook. All right, so how do I prove this? Well, this is y equals e to the x. If you recall, we switched the roles, right? So we'll begin with x equals e to the y. Then take log of both sides, and you have log of e to the y. So you have log x, and you can bring the y in front. It's y log e. But log e is actually 1. So this implies y is equal to log x. And so conclusion, the inverse of x is equal to log x. Now this inverse right here, it's always between 0 and infinity for log x. And one has to be careful with these things. So let's just draw a picture and see what's happening. So this is the graph of e to the x. This is the line y equals to x. And I'll take another color. And this is the line y equals to log, this is the graph of y equals to log x. So if this is f of x, this is f inverse of x equals log x. And one of the geometric applications of this, the inverse, is that they're symmetric about the line y equals to x. So if you put a mirror here, this graph would be this. In passing, I want to mention this. So if you look at e to the x, the domain is minus infinity to infinity, and the range is from 0 to infinity. So when you find the inverse, which is log x, the range of the original function now becomes the domain, which is 0 to infinity. And that was also one of the reasons I didn't want you to, state the domain in the other function, because it would have been too much at that point. For the one on the test. I did not deduct if you didn't do it properly, but I just want to point that out for future reference, because I would deduct in the future. All right, so when it comes to these things, this is important to know. And so we have this fact right here. May I go to the next page, or should I wait?
Just 1 minute, please.
Sure. I do not mind waiting. I mean, it's totally cool. It's not a big deal.
Okay, done. Thank you.
All right, sure. So the textbook that you guys use, I actually bought a copy. And it was interesting. Even though it was cheap, it took over 3 weeks to get to me. So that was a little bit surprising. So I finally got it today. Okay, so I just wanted to comment on, on exponential functions, which you just saw. And now we're gonna get down to, and we also looked at logs last time, and I want to remind you of logs again. So recall the following. And so log to the base b of x is equal to log to the base a of x divided by log to the base a of b. So you're going to say, well, this is all strange stuff. What do I do with this? So suppose I ask you to find the value So I'm going to mute you guys, but if you have questions, feel free to unmute. I have no objections to that. So find a value of log. Can someone pick a positive number for me, bigger than 1? Anyone?
3.
5. All right, so I'll use both. So log to the base 5 of the number 3. Now, if you have a calculator that's more advanced than the TI-84 Plus or Inspire, they actually have this option where you punch these things in, but we would like you to use this formula. And so the 84 or the Inspire doesn't allow, it doesn't give you this option. So we're going to figure this out together. And I'm going to apply this formula. So it's log to the, well, we know log to the base e. So I'm going to put ln. So if I have log to the base 5 of 3, I'll just put ln 3 over ln 5. And this we can all do with our calculator. And in general, if you have log of PQ, you can find this as ln Q divided by ln P. Another thing I should point out, because it's a standard question on the finals, when we ask you to plot that piecewise function, like people put 1 plus x, x less than or equal to 0. I'm just making up an example. Don't forget to put a parentheses around that because it will cause problems with your graphs if you don't. Right, so that was a common error. Kindly address that so we don't have that issue in the future. So this is important if we ever ask you to do problems of this type, pardon me, this is what you would do. And so I wanted to remind you of that. And then some rules for logs that we'll use again today. Log of the product AB is log of A plus log of B. I'm assuming all of these things like P comma Q are positive. So A and B are greater than 0. And if I give you log of A divided by B, this would be log A minus log B. And if you have log of A raised to the B, it's B log A. I mean, what I said here is true, but in this case, I don't need B to be positive. It can be negative also, but you know. So these are 3 very important rules that I'm going to use. Before I do anything though, if I write the cube root of A, what does that mean? Can someone tell me?
A over 1 over 3.
Very good. So that's useful and important. And in general, if they give you the nth root of A, it's A to the 1 over n. And let's just put the most popular one. The square root of A is A raised to what power again? Anyone?
A 1 over 2.
Very nice. So it's 1. And I'm going to use those facts to do some problems now. All right, may I go to the next page?
No, Professor, 1 second.
All right, no worries. Thank you, Nicholas. I got your email. I gave you the credit up front, but I needed to see it. So we're good. I just wanted to indicate. Because we had spoken about it, but I needed to see the work. Lewis, do you have a question?
Oh, no.
All right, I'm looking. Is Nicholas in class? All right, I got an email from him. Yes, I see you here, Nicholas. Yeah, I just wanted you to know that I got your email. All right, so simplify the following in terms of log x and log y. So I'm going to give you some problems, and these are standard kind of test questions. You know, when you get to your next test, you know, you can see things like this. So we want to make sure you know how to do them. So I'm going to work with ln, but if I had put log here, it would not have changed things. And I'm going to do this one with you. So the first thing I'll do is rewrite x to the 5th as x to the 5th raised to the 1/2, and this is y squared. And I'll furthermore write this as ln of x to the 5/2 times y squared. Now, you don't have to do this on a test, like write this out, but I want to remind you of this, so maybe I'll use a different color. So recall, if you have ln of AB, it's ln of A plus ln of B. And I'm going to apply that now, and I'll treat this as A, and this one as B. So this is equal to ln of a, which is x to the 5/2, plus ln of b, which is ln of y squared. Now we're going to do more recalling again. And now recall ln of a to the b is equal to b ln a. So with that fact, I can drag this 5/2 in front. So it's 5/2 ln x, and drag the 2 in front. So this is 2 ln y. So I can take this expression and write it in terms of log x and log y. And so do you see what we did? Are there any questions? So I want you to do this one. So kindly do that, and then I'll work it with you. So I gave you guys enough time, I hope. So we're gonna try to do this. So before you work on the problem, you may want to simplify this portion. So that's precisely what I'm gonna do. All right, good, Jacob, we shall see. So square root of x is x to the 1/2, and this is y to the 5th. And then this whole business here is raised to the 1/2 because they have a square root of that. And so 1/2 times 1/2 is 1/4. And 5 times 1/2 is y to the 5/2. So this is what we're looking at by just simplifying this.
Okay,
And
how does that become x to the 1/4?
well, if you have ab to the n, it's the same as a to the n times b to the n. So if we have x to the 1/2, y to the 5th to the 1/2, it's x to the 1/2 raised to the 1/2 times y to the 5th raised to the 1/2. And 1/2 times 1/2 is x to the 1/4. And 5 times 1/2 is 5/2. Is that good?
So I got x to the square root of 4. So how do I go from that to x to 1/4?
X to the square root of 4 is not correct, right?
Okay.
So the first step is the square root of x should be x to the 1/2. And then when you raise that to the square root again, it's like, raising it to the power half. So you have to be careful. So the only way you should flush this out would be to look like this: x to the 1/4 times y to the 5/2. I want to erase this, but I'll give you guys a moment to copy that because I wanted to do the problem next to that space so you can see what's happening.
Okay, I see that.
All right. So I'm just going to take this out to finish the problem. And it's important that you guys follow this because it'll come back to haunt you in the test, and I would like you to do well on it. Plus, it's important for the other courses. So once we get this, we're going to do the same deal like just now. We'll call this A, and you don't have to tell me this is A if you don't want to. And so this is log of x to the 1/4 plus log of y to the 5/2. And then you'll bring the 1/4 in front, which is 1/4 log of x plus, and you bring the 5/2 in front, it's 5/2 log of y. And so this would be your answer, right? So one of the things you shouldn't make up, and I'm just going to write this and then erase it. You don't have to copy this, but please don't make up rules. I've seen this rule made up a lot. That's not a rule in general. If I give you log of A times B, then it's log A plus log B. I've seen people make up their own rules, and you have to not do that, or else, it'll lead to strange and incorrect answers, right? All right, may I go to the next page? All right, thank you. All right, so the next problem I want you to do is ln. I'll change this back. So this is ln of the cube root of x squared over y times the square root of z. Simplify in terms of log x, log y, and log z. All right, so as in the previous problem, we'll need to simplify whatever is under this, inside this log business. So if I do the cube root, what power is that again?
1/3.
Very good. So what I should do in the first step is the cube root of this whole horrible looking expression can be rewritten as x squared over y, and this x I'm going to write as x to the 1/2, and this whole mess is raised to the 1/3. So are we good with the first step before I continue? Well, you have
Professor,
to
wasn't that a Z or another X?
no, it's a z, so I should write it properly. Thank you for pointing that out. And that's z to the 1/2. So in the numerator, it'll be x to the 2/3, 2 times 1/3. And in the bottom, this is like y to the 1 times 1/3 is y to the 1/3. And z to the 1/2 times 1/3 is z to the 1/6. So first you have to get here before you do anything else. Make sure we're good before I proceed.
Yes.
All right. So this whole problem becomes log of, is someone asking a question? I'm not able to hear you, but Shumi, go ahead.
I was saying like how do you break down the x squared divided by y1? Where did you get the y2?
I'm sorry, I can't hear you clearly. Do you mind speaking a little bit louder or turn up your volume?
Second part, how did you, where did you get the y1? Why I understand the y1, but where did you get the y2? Z y2.
Oh, it might be my handwriting. So this is the square root of z, right?
Yes,
And that
yes.
means z raised to the 1/2. That wasn't meant to be a y2. It should have been power 1/2. So if it looks like y2, it's not. So this is 1/6. Is that better? Square root of z is z to the 1/2. These are not y's, so this is 1/3 and this is 2/3. So if it looks like y3, which I'm guessing that's how you're reading it, it's not correct, right? Is it clear now?
Yes, thank you.
Sure, no worries. So now we're going to use this property log of a over b is log a minus log b. So we'll do log of x to the 2/3 minus log of y to the 1/3 z to the 1/6. I can bring the 2/3 in front, so it's 2/3 log of x minus, and now we have to use the property of a product. Log of AB is log A plus log B. So this would be ln of y to the 1/3 plus ln of z to the 1/6. So it's just 2/3 ln x minus, bring the 1/3 in front and the 1/6 in front. So it'll be 1/3 ln y plus 1/6 ln z. And if you distribute the minus sign, you'll get 2/3 log x minus 1/3 log y minus 1/6 log z. And so this is in terms of log x, log y, and log z. Is that clear? So any questions, or are we good? So, as I pointed out, logs are very important. But before we get into the applications of it, we want to make sure we get the hang of the properties of logs. And that's what we're looking at the moment. All right, so continuing, let's solve some equations. Solving equations.
Professor, can you go back 1 second?
Sure. There you go.
All right, I'm good.
All right, cool. So solving equations. So I'll give you a variety and let's see how we'll do that. Solve for x. So these, some of them you would know how to do because we've done similar examples before. So 2 to the x plus 7 equals to 32. Let me write this a bit better. Ten to the 2x minus 8 is equal to 0.01. Part C, 7 to the 2x minus 3 is equal to 7 to the 5x plus 4. Part D, log of 3x minus 5 equals log of x minus 1. And a slightly more difficult one, log of, so we'll just write as ln of x plus ln of x plus 4 equals ln of 5. And so we know some properties. I just want to list them here. Log of e is 1. E to the log of any number, we'll just say a is greater than 0 is equal to a. So these are useful properties that we're interested in using. So I am gonna pause for a moment. And so if we're doing part F, can you tell me how to start this? What would be your first step? Anyone? So I'm gonna randomly call on people. Angela, can you tell me what to do?
Would you divide by 2.5?
So you have to be careful. And this might be the way I wrote this. This was on me. So if you treat this as 2.5, basically, there's not much you can do. The strategy would be to take log of both sides. But if if I had written 2 times 5, then it would have been different. So it's 2.5 raised to the x is log of 7. And then can you tell me what to do next? or anyone, as a matter of fact.
Bring down the exponents, breaking down the
Yeah, you
exponents.
might want to drag it in front. So it'll be x log of 2.5 equals to log of 7. And if you divide both sides by log of 2.5, you'll end up with x equals log of 7 over log of 2.5. Right? And then you would work this out. I would recommend you do it to 2 decimal places. And I don't know, I mean, this was part F, so I don't know if people got all the way over to part F, but if you did, before the last step, this should be your answer. And then you would use your calculator to get the rest. If there are any questions on part F, please ask.
Can you rate it as log 7 over 2.5?
No. But let me make sure I understand what you're saying. This?
Yeah.
No. So what you would need to do is press log 7 on your calculator, divide by log of 2.5. Because this means something else. This means log 7 minus log 2.5. It's not the same as this, right?
Yeah. Okay. Yeah. I see what you're
No
saying.
worries. I'm glad you're asking because I don't mind if you ask, before the test. It's important to understand what's happening, but I don't want you guys to do it wrong on the test. No. May I erase F? I want to, put all of them on this page. So we're going to do part E. So I should remind you of some rules. If you have a to the n plus m, it's the same as a to the n times a to the m. One of the rules I mentioned is e to the log of anything. So I'm going to say f is the same as f. Well, we expect f to be positive. So you would not have seen one of these before, but the key here is to use this property right here. And I'll say it in the following manner: exponentiate both the left and the right sides. And so that's what I'm going to do. And so what that means is I'll write this as e to the log x plus log of x plus 4, which is e to the log 5. So are we good so far? So I just took this and I made it e raised to this. That's what it means to say the word exponentiate. And I made this e to the log 5, and this is what I have. Well, in light of this formula, what would you say this is? Anyone? So if you have e to the log of, very good, very good. So this would be 5. And what is this side?
X times x plus 4.
Excellent. So I'm going to do it in 2 steps. A to the n plus m is a to the n times a to the m. So this would be e to the log x. This is like my a. Excuse me, this is like my n. Let me write this better, sorry. So this is my n and this is my m. So it's e to the n times e to the log of x plus 4. And then e to the log x is x. And e to the log of x plus 4 is x plus 4. So Akmal, you would be so is this good so far? So we have this. I'm not close to solving this yet. I still have a bunch of work to do. I need to go back And the work I need to do here, I just want to erase some of this to make room. I have x times x plus 4 equals to 5. If you distribute, this would be x squared plus 4x equals to 5. And if you subtract 5 from both sides, you have x squared plus 4x minus 5 is equal to 0. How do we factor this, anyone? What do I put in there?
-1
Minus 1 and
plus 5.
plus 5, yes.
5.
Because -1 times 5 is -5. -1 plus 5 is 4. And then if you solve this, it means x minus 1 is 0, x plus 5 is 0. And so x is 1 here, x is -5. So are we done here, or is there something wrong? Or are we good?
And we have negative numbers, we had to reject.
Very nice indeed. So this one gets, let me put it in red if I can. We'll reject this and we'll accept this. Because if you plug in 1, you're okay, but think about it. If x is -5, log of -5 doesn't exist. Because when it comes to logs, you can only have positive, log of a positive number. Any number that's less than or equal to 0 you cannot find a log of those numbers. So we'll avoid those things. And that's precisely what we've done here. So are we good so far? All right, I'll give you a few moments to copy everything because I do want to erase this so I can fit the other one in. Are there any questions on part E? If you have questions, feel free to ask. And I will do my best to clarify. And the question I have for you, is it okay to erase now or should I wait? Well, the next one we'll do is part D. So because I did them like the last one first, you know, this one was a little bit harder than what you would run into. But so part D would not be as difficult, I believe, but you will be the judge of that. You will let me know. So we're doing part D right now, and we have log of 3x minus 5, which is equal to log of x minus 1. What would be the strategy here? Because you want to get rid of the logs. And in the previous problem, you saw the way to get rid of the logs was to exponentiate both sides. So what would you do here?
Plug in both sides.
Yeah, you would do the same. So it'll be e to the log of 3x minus 5 is e to the log of x minus 1. So exponentiate both sides. And so there are going to be similar problems like this on your test, and I would like you to do the same thing. So when you do e to the log, these two cancel each other out because they're inverses. And so we got 3x minus 5 is equal to x minus 1. Well, how do we solve this? We'll add 5 to both sides. And we have 3x is equal to 4. Divide. So I hope you're with me so far. If you have any questions, let me know, please. And I should write this properly. This is x plus 4, pardon me. Then if I subtract x from both sides, I'll end up with 2x equals to 4. How do you solve for x? Divide both sides. Right? Go ahead.
I was saying about divide by 2.
Very good. Yes. And you're 100% correct. And so we end up with x equals 2. And then it's always important, always check the answers. And especially on the finals and in our tests, you know, there's good chance we may end up rejecting one of the answers. So it's always helpful to check you figured, and it's instinctive. When I was a student, I'd do all of these work. I'm like, oh, so I'm done now. But then you have to go back and check, because it doesn't mean they're always good, the answers. So when we take 2, 3 times 2 is 6, 6 minus 5 is 1, log of 1 is 0. And here, if you put in 2 minus 1, it's 1 log of 1. So log 1 equals log 1. I know my answer is good. So now I can, check that off as something that works. But in general, you can't assume that they automatically work. You do need to check your answer. So that's super important in that sense. And, once you see a few of these in play, the idea is you follow the same pattern. And a little bit later tonight, we'll talk about applications, which will deal with exponential growth and decay. And when we talk about those things, we may have to use this or use these techniques. So one of the things that you've learned is how to play around with exponential equations, and more precisely, how to solve them. So one can solve them nicely, and this works really well in this instance. May I erase this, or should I wait? If you have any questions, let me know. So I'm gonna start with number 1 first. Order doesn't matter, but it's always useful. So when I say number 1, part A, we have 2 to the x plus 7 is equal to 32. May I ask how to begin this? Anyone? How do you start this problem?
I put the right side to the 2 to the exponent 5 to get the same base.
Okay, that's an excellent suggestion. But let's say that wasn't the case. What would you do otherwise?
You just log of both sides.
Yeah, and so that's a nice suggestion. So we'll do log of 2 to the x plus 7, which is log of 32. And we have to drag this whole thing in front. So it's x plus 7 log of 2 is log of 32. Now, if I divide both sides by log 2, I'm going to have x plus 7, excuse me. So we have x plus 7 equals, can you guys do this with your calculator and tell me what it is? Anyone? Excellent. So you guys got 5. And if we're solving for x, you'll subtract 7 from both sides. And you have x is equal to minus 2. And you want to check this. So it'll be 2. So this is the check, I should say. We have 2 to the minus 2 plus 7 equals 32. 2 to the 5th equals 32. And 2 to the 5th is 32. So we know it works. Is that clear? So are we good so far? Well, Lewis was making another suggestion, and so this I'm going to call method 2. But in general, you're safer using the method I used in A, because 9 out of 10 times things are not lined up this nicely. But you can try the problem like this: 2 to the x plus 7 is equal to 32. But it turns out 2 to the 5th is 32. So you can write here 2 to the 5th. And if you do that, then there are a couple of ways to do the next step. You can compare the coefficient, the exponents, pardon me. Give me 1 minute. Yeah, you can compare the exponents and just say x plus 7 equals to 5. Subtract 7 from both sides and you'll get x equals negative 2. So this is nice when it works, because for all intents and purposes, you don't have to do a lot of work. Do you always see this? No. So I've seen students go through the whole process if you can spot this, that's beautiful, and you'll get the answer quite nicely. But there is no issue if you don't get it right, right away. Yeah, I mean, this is absolutely correct. There's nothing wrong with this. And then the other way, which complicates people's lives, would be to do log to the base 2 of both sides. And then, you'll drag the x plus 7 and the 5 in front. So this is how you can do this in 2 ways. So that was part A. So if we follow Lewis's work in part B, we have 10 to the 2x minus 8. How would you write 0.01, 10 raised to what power? Anyone? Any ideas? All right, 10 to the minus 2. So if you actually saw this, then there's no work to do. It's just a matter of setting 2x minus 8 equals minus 2. And if you have 2x minus 8 equals negative 2, you'll add 8 to both sides. And you end up with 2x equals to 6, or x equals to 3. And it doesn't take much to check. If you let x equals to 3, 2 times 3 is 6. 6 minus 8 is negative 2. So 10 to the minus 2 equals 10 to the minus 2, and we're done. So that's a nice way to do it. You're not obligated to do it this way. If this is not clear to you, you can just take log of both sides. So you can do it the way I just did it here, and you'll get the same answer. So I will wait a few moments until you're done copying this, and then I'll do part C last. So I feel part C is the longest one. I don't think it's the hardest one, but it involves more work than the other ones, so to speak. May I erase everything? Is that good, except part C to work it? Are you guys good? All right, so I shall begin. Thank you. So this is standard kind of an exam problem. So you want to be very careful with this when you get these kinds of problems. And they may not give you both sides. So doing this is not such a big deal. You will just equate these two. 2x minus 3 equals to 5x plus 4. And then you will add 3 to both sides. So you get 2x is equal to 5x plus 7. Then if you subtract 5x from both sides, you end up with negative 3x is 7. And then if you divide both sides by negative 3, pardon me, x would be minus 7 over 3. And are we good with this before I continue? Okay. And if you guys agree with this, that's a good thing. If you don't, we can talk more about it. But the idea would be you would want to plug in or substitute in here and make sure that whatever it is that we're doing makes sense. So step 1, you set the exponents equal. 2x minus 3 equals 5x plus 4. You add 3 to both sides, you'll have 2x equals 5x plus 7. If you subtract 5x from both sides, you have minus 3x is 7. Divide both sides by negative 3, and you get minus 7 over 3. So as a way of checking, and you shouldn't ignore this, it'll be 7 to the 2 times minus 7 over 3 minus 3, which is 7 to the minus 14 over 3 minus 3 over 1, which is 7 to the minus 14 over 3. The LCD is 3. So it's minus 9 over 3, which is 7 to the minus 14 minus 9 over 3, minus 23 over 3. So that's what I meant with this one is the longest, because it's messy to check this. And then we have to check the right side. It's -7/3 plus 4, which is 7 to the -35/3 plus 4, which is 7 to the -35/3 plus 12/3, which is 7 to the -35 plus 12/3. 7 to the -35 plus 12/3. And this is 7 to the -23/3. So they check, so you know you're correct. Is that clear? Yeah, I'm actually gonna, so at the end of classes, I will send you guys a link and I'll give you the homework problems to do for tomorrow, and it will include everything that we've done today so far and a little bit more, right? So I may ask you or may not ask you on the test, but I always recommend that you check because it's a trap. Like if you don't check it on the exam, you might say something is a solution when it's not. They don't always work, especially when you're doing logs. So even though I may not tell you, it doesn't mean that you shouldn't check, because if you don't check, you might make the wrong conclusion, right? So there's one more problem I want to do on this. Like suppose we have 5 to the x, 5 to the 2x equals 3 to the x minus 5, and this is x minus 1. Let's go with plus 5. So solve this. So tell me how to solve this. We can do this together. Anyone?
You said the exponents equal?
No, so this was deliberate and this is a trap. These guys are not the same, right? So you can only do that when the bases are the same. Any other suggestions? Well, we have no choice but to log both sides the usual way. So it would be log of 5 raised to the 2x minus 1, which is log of 3x plus 5. And then you're going to use the rule where these guys get dragged in front. So it's 2x minus 1 log 5, which is equal to x plus 5 log of 3. So there are a couple of things I can do. I'm going to do it in a slightly longer way just to make things easier, I think. And students tend to like this way better. But like one cheap way to do it is to divide both sides by log 5, but I'm not going to do that. I'm going to multiply these guys. So it's 2 log 5x minus log 5. And then if you distribute here, it's equal to log 3x plus 5 log 3. I'm going to add log 5 to both sides. And so you have 2 log 5 times x equals log of 3 times x plus 5 log 3 plus log of 5. Then I'm going to group the x's together. So I'm going to subtract log 3x from both sides. And so these two guys will cancel out. So we get 5 log 3 plus log 5. And on this side, I have 2 log 5x minus log 3x. So I can factor out the x. So I'll have 2 log 5 minus log 3x, which is 5 log 3 plus log 5. So that's what makes this one nasty, because there are so many steps, especially when these bases don't match. And then I have to divide both sides by 2 log 5 minus log 3. 2 log 5 minus log 3. And so that would imply that x is equal to 5 log 3 plus log 5 over 2 log 5 minus log 3. But here's the thing, you can move the 5 up if you wish, or just use your calculator at this point. So you can go 3 to the 5th minus log 5. And this is log 5 squared minus log 3. 3 to the 5th, 3 times 3 times 3. What is 3 to the 5th, anyone? It will be log of 243 minus log 5 over log of 25 minus log 3. I would accept this as the answer and then use your calculator, but I'm going to simplify it a little bit more just to show you the full power of the logs. So when you have a log of differences, you can combine them together as this, divided by log of 25 over 3. But at this point, I can't go further. You have to use a calculator. But I want to say it's okay up to here, and then you can use a calculator. Is that clear? You have any questions? So I needed to give you one with a different base or 2 different bases, because if you didn't have one of those, it's misleading. You might have set them equal. I wanted to make sure that you're clear about that. That's not gonna work. And it's easy to fall into that trap. And I did not want you to be in that situation at all. Right? So there should be a plus. So this, one has to be careful here. So this is not quite, so that's a plus sign, and this would be a plus sign. So everything is good up to here, but except for this, should be a log of 243 times 5. Right? And the rest follows. But I'll reiterate again, I'm totally okay if you do up to this point where I said okay, and then just use the calculator, right?
1.
Can it b raised to the 0 is 1? Excellent. So it's c times 1, which implies c is equal to 1. Is that clear? Now they also ask us to find the value of b. So let's see, and they gave us this. So I'll start with f of x equals c times b to the x, but we know c is 1. So f of x is actually b to the x. Since c is equal to 1, I just plugged it in. Well, now, because they gave me f of 1 is 20, I'm going to run with that and see how that gives me the answer. So f of 1 is b to the 1. But what was f of 1? It's 20. 20 is equal to b to the 1, which implies b is equal to 20.
How does c equal 1?
Repeat the question, please.
How does c equal 1? Like,
well, we were given f of 0 is 5, right?
Yeah.
So if I plug it in, I have f of x is this. So f of 0 is c times b to the, well, x is 0. That's what it means. F of 0 means when x is 0. So f of 0 equals 5 means when x is 0, y is 5.
Oh, okay.
Right? So we'll have 5 is equal to c times b to the 0, which is 1. So we're not done yet. Now we've found b and c. So we saw that b is 20 and c is equal to 1. And we started with this model, f of x is c times b to the x. So what exactly is f of x? We want to get rid of the letters. Well, c is 1 times 20 to the x. Well, 1 times anything is that. So f of x is actually 20 to the x. When you guys are done copying, let me know. We'll do some more of this. Excuse me. So same problem now. Suppose we give you, so I'm going to call this part B, f of 0 equals to 3, f of 4 equals 48, and f of x is equal to c times b to the x. I want you to find b and c. So please do that. I'll give you a few moments to do that, and then I'll work it with you. All right, so let's see if we can do this together. So we're going to use f of 0 equals 3. And we have f of x is equal to c times b to the x. So f of 0 means I'm putting x equals 0. It's c times b to the 0. F of 0 is 3, which is c, because b to the 0 is 1. And so we're halfway done. We found c. We have to find b, so hopefully the rest will give us that. Now we have f of 4 is equal to 48. So f of 4 is equal to c times b raised to, well, if you look at this, this says x is 4. So what that means is going to be b to the 4th. Well, what is f of 4? Is 48. What is c? It's 3 times b to the 4th. So here's where I'm at. I have 3 times b to the 4th is equal to 48. What do you think I should do here? Anyone? Well, how do you get rid of the 3? Very nice. Yeah, you would divide both sides by 3. And so what I'm going to have here is b to the 4th is equal to 16. How do I solve for b here? What's the strategy here to solve for b?
The square root.
Well, you can't take the square root. You would exponentiate by 1/4. So it'll be b to the 4th raised to the 1/4, which is equal to 16 raised to the 1/4. And so b would be equal to the 4th root of 16. Or you can just punch this in your calculator, 16 raised to the 1/4, or 0.25. And b is equal to 2. Now, if you actually do this, it's plus or minus 2, but we already agreed that, when we're working with c times b to the x, this is between 0 and 1, or it's greater than 1. So the bottom line would be f of x is equal to c, which happens to be 3 times 2 to the x. And this is how I would write it. So what it says here is when x is 0, this is what we'll do. And we can go on and on with this sort of thing. Are we good so far? All right, so I want to do one more before I go to, an actual application. May I go to the next page? Excuse me.
Professor, before to, can you explain in the last step, b is equal to 16? What is a 0.25? The last part of what we did.
Are you good up to here?
Yes.
Well, these two cancel and you get b. This was the calculator command. Like when you hit 16 raised to the power 0.25, that's what I wrote here. 1/4 is 0.25.
Oh, thank you.
Is that clear, or all right?
Yes. Yeah, I was a little confused with that sign that you put in the
Oh,
calculator.
okay. So, I
Yeah.
mean, I don't want you to put this on a test, but I just wanted to show people the calculator command. So maybe we're better off just writing it as b equals to 2. Just to avoid any confusion. All right. May I go to the next page? So here's a word example. Example 1. The mass m of t of a bacteria sample is 2 times 1.02 to the t. After t hours. Part A. What is the mass at the start? What is the mass of bacteria after 4 hours? When will the mass reach 10 grams? I'll write the number 10. So we want to do this problem as it stands here. Can someone tell me what the answer to part A is? Anyone? So the way to think of part A is to think of, like, what is the time when you start out? Anyone? And that will give you the answer. Very good. So in other words, find m when t is equal to 0. So that's m of 0, because we gave you m of t as this, would be equal to 2 times 1.02 raised to the 0. Well, 1.02 raised to the 0 is 1, so it's 2 times 1, which is 2 grams. So you're starting with 2 grams of bacteria at, initially, or when time is 0. So what is the mass of the bacteria after 4 hours? What am I supposed to do here? This tells you to let t, very good, t equals 4, right? So m of 4 is 2 times 1.02 raised to the 4th. Can you guys do this with your calculator, please? And give me to 2 decimal places. So please do that with your calculators and give me the answer to 2 decimal places.
1.08.
1.08. Tell me how you did it so you can guide me, please.
Oh, did you want like the entire equation?
I need this. So I don't know. I want
I,
this
ju
whole.
I just did the exponent first. Sorry, I didn't multiply by
Oh,
two.
okay, okay. No, I just got worried because I don't want you to
So
multiply
it's
by
2.16.
Okay, now that's a whole lot better. All right. Now we're in business. So 2.16. And you guys don't want to give me grams, right? But other than that, all is good. So how do we do the last part? That one looks weird or different. Anyone?
You have to multiply by reach out.
I'm not sure what you mean by that.
Substitute 1 point 0.02 with 10.
No.
10 equals 2 times 1.2.
Yeah, the mass, right, is m of t. So what you would want to do is replace the mass by 10. So let m equals to 10 grams and solve for t. I mean, we're not allowed, and I just want to clarify, we're not allowed to change this 1.02. The only two places I can plug in or substitute for would be m of t and t. Those are the only two guys. So in fact, just to break this down, because you'll run into this on your finals and on my test also, there are two things we can ask you, either to find m when we give you t, and we did that in parts A and B. We give you t equals 0 and t equals 4. Well, part A was a little bit subtle in that it says, what is the mass at the start? Well, at the start would be when time is 0. That's when these scientists, so to speak, started doing their experiment. The other option that one has when they're giving you a problem like this would be to give you the m and ask you to find the t. And that's precisely what was done in the last part. So if m is 10, we'll have 10 is equal to 2 times 1.02 t raised to the t. Now, to solve this, you have to divide both sides by 2, and you'll end up with 5 is equal to 1.02 t. And then, how do you solve this? Well, this is like those earlier equations we were doing. You will take log of both sides. So we have log 5 is log of 1.02 raised to the t. So we have log 5 is equal to t log of 1.02. And then if you divide both sides by log of 1.02, you'll end up with t equals to log of 5 divided by log of 1.02. Can someone tell me what this is? Anyone? How many years would this take, by the way, to get to 10 grams? It's exponential growth. Very good. So I'm going to round it off to 81.3 grams, but your answer is perfectly fine. Okay. And so this is how one would do this. So by the way, you should at least know that this value is going to get bigger. And you're right. So that was, you're on top of things. That was excellent. So it will be 81.3. What should it be? Anyone? It should be hours. So, you have to be careful. Why I said that, I wanted you to be on top of things because unfortunately we would deduct a point here and there if you don't give us the right units. And so me saying years, you should have clearly flagged that, which one of you did. It's clearly in hours, and you can't get time in grams. That would be kind of silly. So that was good that you guys are paying attention to this. So that's important. So keep in mind, you should put the units. Like in part A and B, I was finding the grams, the weight in grams, but in part C, it's the time, right? So we're gonna do more of this very common kind of problem, as I said. May I go to the next page? All right, so the population. So this is example 2, of a country is 12.7 million in the year 2000. And 14.3 million in the year 2010. assuming exponential growth, find the formula that models the growth. So how do you do this? First, you have to start with f of x equals c times b to the x. Now, it's most important, excuse me. So if they ask you to find the formula, basically the most important part would be to find B and C. So in the year 2010, that's when they started out, they have 12.7 million. Do you want to make X to 2010? Does that make sense? Is that a good thing to do? Well, it turns out there's nothing wrong with that, but it might be easier instead of thinking of 2010, instead of writing f of 2010 as being equal to 12.7 million, I'm sorry. We started in the year 2000. So instead of writing f of 2000 as being 12.7 million, we'll start with 2000. The year 2000, we'll say it's 0 year. Count the year as the start or 0. Is that clear to everyone? So in other words, when t equals to 0, f is equal to 12.7 million. So instead of me writing f of x, I'll put f of t because I'm thinking of it as time. I wanted to highlight that. So what do? We have f of 0 equals to 12.7. And we have f of 0 is c times b to the 0. So 12.7 equals to c. How do I know this? Because b to the 0 is 1, and this is what I did earlier. All right. So I have a question for you now. What is t equal to in 2010? If t is 0 in the year 2000, what would t be equal to in the year 2010? Anyone? Very good. It'll be 10 years, right? So we now know that f of 10 is equal to 14.3 million. And so f of 10, by the way, is c times b raised to the 10th. This is 14.3. We know what the value of c is. It's 12.7 b to the 10th. Well, here I got myself some work. I'll divide both sides by 12.7. And we have b to the 10th is equal to 14.3 over 12.7. So b is equal to the 10th root, or this raised to the 1/10. Can someone tell me what b is equal to in this problem? So can you work out what is 14.3 divided by 12.7 and raise that to the 1/10? What did you guys get? Anyone? And it's important that you try this even if you don't get it out, because when you get tests and things like that, you want to be able to handle these things easily. You don't want to have trouble doing it. So now is the time to learn how to do it. We're not judging you at the moment.
I got 1.01.
That sounds good. If you round it, it'll be 1.02. well, okay, so I'm gonna give it like an extra decimal place, so it'll be 1.012. But I'm okay with what your value. So if we do it to 3 decimal places, so I got myself B, which is this, and I got C, which is that, and I'm gonna write that out. There are more questions I have for you on this problem, but the most important part is to get the right formula. So notice, Christian and you both give me the right answer. I'm just gonna round it to 1.012. And so we have A is equal to something, and B is equal to something. So what is A? It's 12.7. And B is equal to 1.012. So the formula is normally C times B to the X. So we have F of X is equal to, I need to put C here, 12.7 times 1.012 to the X. Right, so that's most important. So now we have a part B. What is the population in 2015? So can someone tell me what's the population in 2015? So I wrote F of X. If I write F of T, it would just change. So what is X equal to in this problem, or T equals to, depending on what you're calling time? So if 2000 is 0, 2015 would be what?
15.
Very good. So it'll be 15 years. And F of 15 would be 12.7, 1.012 to the 15. Can you guys work this out and tell me what you get? Can someone give me an answer? I think you're wrong. 0.2. Yeah, I'm getting 15.2 also, or approximately, and that's pretty good. And that's something they make projections with. If you replace this by the number of COVID virus that's floating around, and there was a point when it was growing exponentially, and this was what's happening, and it's not a cool thing, obviously. So we're hopeful that it will go into negative territory one of these days. All right, so you guys are awake. All right, so just checking. All right, and that keeps you guys on your toes. Very nice, Louis. So, so we're thinking million at this point. Okay. So when will the population reach 18 million? And so basically we gave you this value here, the F of X, and you have to find X. So when F of X is equal to 18 million, no trick there, find X. So what we have is 18 equals 12.7, 1.012 to the X. Well, how does one solve this? Well, first you would want to divide both sides by 12.7. And we have 18 over 12.7 equals 1.012 to the X. Then you take log of both sides. And it'll be log of 1.012 to the X. And you bring the X in front. So we'll have log of 18 over 12.7, which is x times log of 1.012. And ultimately, when you're doing this problem, you might want to start doing your calculations early. So whatever this number is, log of 18 over 12.7, you have to divide, oops, pardon me. You have to divide both sides by log of 1.012. Can you please do this and estimate? So here we want to know what year this happened in. So when will the population reach 18 million? So see if you can tell me what that is, please. Anyone with a number? So you got to do log of 18 divided by 12.7, work that out first, then divided by log of 1.012. And let me know what number you came up with. All right, 29.24. That's excellent. So I have a question for you now. Is this the answer that they're looking for when I ask you when will the population reach 80 million? Do you think that's the answer I'm looking for?
No.
I want the year, right? So what year would it be? Very nice. So in the year 2029, because if you're 29.24, at some point in the year 2029, you'll hit 29.24 years. So in the year 2029, the population would grow to about 18 million, right? No tricks in my answer there. It's all straight up. So that is super important. That's something, you would have to do. And that's really, really, really important. Can I go to the next page or should I wait? All right, thank you guys. So what we have here is f of x is equal to c times b to the x. So note for growth, so I'll write it out in a better way. So this is an important variation in the formula that you need to know. If I tell you that the rate is growth, you can find b by using, so b is equal to 1 plus r for growth, and b is equal to 1 minus r for decay. R is the rate. So if I tell you what the rate is, if you add 1 to the rate, then it's a growth. And if you subtract r from 1, it's the decay. And that's very, very important. So copy that, and then we'll do one problem related to that. Can I go to the next page? All right, so here's an example. An unstable element decays at a rate of 5.9% per minute if 40 milligrams of this element is present. How long will it take until 2 milligrams are left? And this is a carbon copy of the kind of problem you'll get on a test. So let's see if we can work this. This is a good problem to work on to cap things off. So as far as we're concerned, the formula is f of x equals to c times b to the x. So when you see the word decay, what is b equal to? Can someone tell me? Well, first of all, the rate is 5.9%, which is 5.9 over 100. And what is that equal to? Anyone?
0.059.
All right, thank you. So the rate is this. Can you tell me what b is? Anyone?
1 minus r.
Very nice. Yeah, 1 minus r. So b is equal to 1 minus 0.059. Can someone tell me what this answer is? What is 1 minus 0.059? I know it's trivial for most of you, but we still want you to.
941.
Point what?
941.
941. Thank you. Is everyone in agreement? That looks good to me. So we have here now that f of x is equal to c times 0.941 to the x. They gave us crucial information here. If 40 milligrams of this element is present, and we're thinking of this at the start, it would mean when x equals 0, f is equal to 40 milligrams. So in other words, f of 0 is equal to 40 milligrams. And so you would have f of 0 is equal to c times 0.941 to the 0. F of 0 is 40 is equal to c, because anything raised to the 0 is 1. So before I do anything else, I'm going to call this part A. I know what the equation is. And the equation is f of x is equal to c, which is 40 times 0.941 to the x. So the big question here now is how long will it take until 2 milligrams are left? So what they did is they gave us f of x is 2. Find x. I'm using x here as time. So you have to substitute. You'll have 2. So I'm going to call this part B. So 2 is equal to 40 times 0.941x. The first step is to divide both sides by 40. Excuse me. And you'll have 2 over 40 is equal to 0.941x. What is 2 over 40? Anyone? Isn't that 0.05? Is equal to 0.941 raised to the x. Very good. Take log of both sides, 0.05 is equal to log of 0.941x. I have to go to the other page in a minute, and then we'll solve this. So bear with me, I'm just going to the other page to solve this. I'll come back. So log of 0.05 is equal to, and we have here, we'll bring the x in front, x log of 0.941. And if you divide both sides by log of 0.941, we'll have x is log of 0.05 over log of 0.941. Can someone tell me what this number is? I will in a minute. Can someone work this out, please? 49.3. What would the answer be in what units? Anyone? Hours, years, what? Minutes. All right. All right. As promised, I think many of you won the previous page, so I will go back.